Welcome back. This is the second video for the Chapter 2 part, or Test 2. We are starting with question number 5. Question number 5 says, express negative 13 pi over 3 in terms of exact degrees. Well, with question 3, we saw that degrees to radians multiply by pi over 180. Now we're going backwards, so we're going to multiply by 180 over pi. So radians to degrees multiply by 180 over pi. And again, you want your units that you're going away from to cancel out. So our radians will cancel out because I have my radians here, and then I'm dividing by my radian unit on the 180 over pi fraction. And I usually say you want your pi's to cancel out. That's technically not the right terminology, but it's a good reference tool for most of these problems. We want to go to degrees, and I want the 180, the degrees, to be on top. I want those to stay there when we're finished. So to do this, negative 13 pi over 3 times 180 over pi, multiply straight across, that would give you negative 13 times 180 is negative 2,340 pi, don't forget that, all over 3 pi. And you can probably just put all this into your calculator directly as it is, because the pi's will cancel out nicely. And we'll be left with negative 2,340 divided by 3. And if you simplify that, that's just negative 780 degrees. So this problem was just testing your knowledge of, do you know how to get to degrees from radians? And number 3 was testing your knowledge of, do you know how to get to radians from degrees? Question number 6 is testing your knowledge on where the trig functions are positive and negative. So we haven't necessarily dealt with this terminology too much, but I've spoken about it and I've said it physically. I've said it in class. In which quadrant will the terminal side of theta lie, given that sine of theta is less than 0 and secant of theta is greater than 0? Well, less than 0, what numbers are less than 0? The negative numbers. So that tells me that sine is negative and secant is greater than 0. So what numbers are greater than 0? The positive numbers. Sine, I know, on the unit circle is y over r. Since we're on the unit circle, my radius is just 1, so we're going to focus on just the y. So let me do a little key here. We'll put sine in red, and we'll do secant in purple. All right, so if we're on the unit circle, we're focusing on just the y. So if sine is negative, that means that y is negative. Where is y negative? In the 3rd and 4th quadrants. Secant is r over x. And since, again, we're on the unit circle, r is 1, we're going to focus on just the x. Because the reciprocal of x, whether it's positive or negative, is still whatever sign it was before. The reciprocal of 1 is still positive 1. The reciprocal of negative 1 is still negative 1. So we're going to focus on secant in terms of x. Where is x positive? Well, x is positive in the 1st quadrant and in the 4th quadrant. And this question is saying, where does the terminal side of theta lie, given that sine is negative and secant is positive? Where do these two pieces of information meet up? Where do they coincide? And that happens in quadrant 4. So when you're dealing with these types of problems, focus mostly on x and y. R has nothing to do with the positive negative aspect. So you're only going to focus on, is this trig function x, or is it y, or is it both? And be very careful with cotangent and tangent. If tangent and cotangent is positive, then it's either in the first or the third quadrants, because your ratio of x to y and y to x could be both positive or both negative. If cotangent and tangent are negative, then that means that either x or y, not both, are negative. So for cotangent and tangent, they are both negative in the second and fourth quadrants, positive in the first and third quadrants. Next page. Problem number 7. Find the degree measure of the angle with 2/5 rotation clockwise. It's very important that you pay attention to the direction. So I like to draw myself a diagram. 2/5 rotation clockwise. That means it's going in this direction, and it's going 2/5 of the way around the circle. When I was explaining it to the groups today in class, I said, if I went all the way around one rotation, that would be how many degrees? 360 degrees is one rotation. If I did half the way around, half of a rotation to the negative x-axis, we know that would be 180 degrees. Let's say I did a third of the rotation. That would be 120 degrees. How am I getting this? Well, if I take these two numbers, and with respect to a full rotation of 360, how do you get from 1 and 360 to 360? Well, the only way that it would stay as 360 is if you multiply or divide. How do you get from a half and a rotation of 360 to get to 180? And if you notice, 1/2 times 360 is 180. 1/3 times 360 is 120. So that's why to go from rotations to degrees, multiply by 360 degrees. Why? We say this is 2/5 of a full rotation, 2/5 of 360 degrees. And of usually means multiply. So we take 2/5 and multiply by 360. We get a degree measure of 144 degrees. And we can stop there. That's it. Now, I did forget something. I said to pay attention to the fact that it's clockwise. If it's clockwise, we know that the degree measure is negative. So that's going to have to be a negative 144 degrees. If you want, you could say, okay, I'm going clockwise, so I'm going to make that a negative 360 degrees. If these are all going clockwise, their degree measures will all be negative. So 2/5 times negative 360 gives me clockwise rotation of 2/5, or negative 144 degrees. For problem number 8, express the degrees, minutes, and seconds in decimal degrees. I'm going to require that you show me the setup for how to get this answer. You can use your calculator, that's fine, but I need the setup. Now, treat your degrees like your hours. Your minutes are the middle term, and your seconds are your last term. We know that there are, for every 1 hour, there's 60 minutes. For every 1 minute, there's 60 seconds. Or for every 1 hour, there is 60 seconds times 60 minutes. Or in other words, 1 over 3,600. So 1 hour has 3,600 seconds. 1 hour has 3,600 seconds. So based on this information, you would take your whole degrees and add that to whatever portion your 14 minutes is of an hour. So how much of an hour, in this case, I guess of means divide, is 14 minutes. So we could say of means divide, so we divide by 60, or of means multiply by 1 over 60, 1 hour for 60 minutes. So what I was explaining in the class was, if you had said that you worked for 20 minutes, how much of an hour is that? Well, that's a third of an hour. How'd you get that? You divide by 60. So you worked for 14 minutes. How much of an hour is that? Divide by 60. You worked for 16 seconds. How much of an hour is that? Divide by 3,600, the number of seconds in a minute in an hour. And once you get all that, you can just put it into your calculator, whatever answer you get. 235 plus 14 over 60 plus 16 over 3,600, which gives me 235.3 decimal places, 238 degrees. Now you can use this as an excellent check, because if you know how to put it into your calculator, then you can see if you use these values right. So to put it into your calculator, you would do your whole degrees, 235, second apps for angle, and 1 for degrees. Then you do your minutes, 14 second apps, 2 for minutes, and 16 alpha plus, the plus symbol, for your seconds. If you have it written in there like that, exactly as it looks on your paper, you hit enter. If we get the same answer as we did when we did it all out, then we know we did something correctly. We did the right strategy. If you get a different answer from here, then you might want to check either how you put it into your calculator or what you did within the formula here. So use that as a check for yourself.